Today we're going to talk about chapter 21, which is the nuclear chemistry chapter. And so let's kind of review some things we know. We know from the start of chapter 3 that we have the law of conservation of mass, which says that matter cannot be created or destroyed under ordinary chemical reactions or physical changes. So in nuclear chemistry, this is where we no longer take into account the law of conservation of mass, because in this case, we can actually have matter that's converted into energy. All right, number two that we should already know is that we would have already spent some time looking at that atoms have protons, neutrons, and electrons, and how to use those particles to determine mass number and atomic number when we're going to use those items today. So you're going to need your periodic tables today. So if you need to pause the video to get out your periodic table, then do so. Now, there are lots of parts to nuclear chemistry that are covered throughout the curriculum in the science department. So we're just going to focus on nuclear reactions in chemistry. So let's define radioactive decay. So radioactive decay is defined as the spontaneous disintegration of a nucleus into a slightly lighter nucleus. And we get with that an emission of particles, an emission of electromagnetic radiation, or we can have both. So I'm going to write that definition in this space here. All right, so we are going to talk about 5 types of radioactive decay. And we're going to practice writing the equation for each of the 5 types. So what you'll have to do in this section is be able to write your own equations given information, just like I've given in my examples here today. All right, the first type we're going to talk about is alpha emission. And so there are a couple ways we can represent an alpha particle. So one is to use this symbol, but an alpha particle is technically a helium nucleus. So the other way we can represent the symbol, which is the way I'm expecting you to represent the symbol, so we're writing nuclear symbols in this section. So we should know that this superscript number is the mass number, and the subscript number is the atomic number, and He is the symbol for helium. Okay, so let's look at my example here. So I say that the nuclide thorium undergoes alpha decay. So thorium is going to be on my reactant side of the equation. And so we're going to need to find thorium on the periodic table. So its symbol is TH. Okay. Now, this notation they've given us, we should know is hyphen notation. So that 232 is going to be the mass number. And so once you find TH on the periodic table, we would then know its atomic number is 90. All right, now the nuclide that you're starting with, this is referred to as a parent nuclide. Now it undergoes alpha decay, so that means this alpha particle is given off, so we're going to write the symbol for the alpha particle. And in this case, we're not converting mass into energy, so our mass here is going to be conserved. So this means that if I take the mass number of thorium and I subtract the mass number of helium, and I'm doing that because thorium's on the reactant side and helium's on the product side, this will give me the mass number of my new nucleus. So 232 minus 4 is 228. And we can do the same thing with the atomic number. So 90 minus 2 gives me 88. And then we're going to go to the periodic table and find atomic number 88. And we're going to write the symbol for that element, which is Ra. Now, this new nucleus that's produced here, this is known as the daughter nuclide. All right, so that's type number 1. Type number 2 is beta emission. And this is really a high-speed electron. So electrons, remember, have no mass, so the mass number is going to be 0. We use its charge here for its atomic number. And then it uses the letter beta, which looks like this. So let's look at my example. So the nuclide radium-288. So this is going to be my parent nuclide. So we're going to write the symbol for our radium, which is Ra. The 288 is its mass number. And if you find Ra on your periodic table, we can see that its atomic number is 88. It's going to undergo beta emission, so it's going to give off a beta particle. So we're going to write the symbol for that beta particle. All right, so then we need to figure out the daughter nuclide. So again, if I take the mass number of the reactants and I subtract the mass number of my product, this will give me the mass number of my daughter nuclide. And if we take the atomic number of my parent nuclide and we subtract the atomic number of my beta particle, so remember we changed the sign. So we're really adding these two together. So this is going to give me 89 here. We're going to find 89 on the periodic table, and its symbol goes here. So this is actinium. All right, type number 3 is called positron emission. And its symbol looks like this. So this is also a beta particle. Okay, so it doesn't have a mass, but it has a positive charge instead of that negative one that our high-speed electron had. Right. So oxygen 15 is my parent nuclide. So we're going to find oxygen on the periodic table, and you would see that the whole number in the box is an 8, so the atomic number is 8. It's going to undergo positron emission, so we're going to write the symbol for the positron particle. And then we're going to determine the nuclear symbol of the daughter nuclide. So again, if I take the mass number of my daughter or my parent nuclide and I subtract the mass number of my particle, this is going to give me the mass number of my daughter nuclide. If I take the atomic number of my parent nuclide and I subtract the mass number of my particle, this is going to give me the atomic number of my daughter nuclide. So then we would look up atomic number 7 on our periodic table and write the symbol of atomic number 7 here. So this is nitrogen. All right, we have one last type to look at, and this one is the one that you are not going to be expected to write nuclear equations for. And the one we're going to end with is gamma emission. And gamma emission is energy, it's no mass. So the nuclear symbol for gamma emission will look like this. And the symbol that I've written is the letter for gamma. And this is just an example, because again, you're not going to be expected to write equations for gamma. So in this case, my parent nuclide is uranium-238. It's going to undergo gamma emission, and actually it gives off 2 gamma particles. This equation also gives off an alpha particle. And again, if I take my parent nuclide and I subtract my particle atomic mass numbers from those values, this would be 234. And if I took my parent nuclide's atomic number and subtract the particles' atomic numbers, we get 90. And if I look up atomic number 90 on the periodic table, this would be thorium. Okay, so you are to insert your notes into the Google Doc and then make sure you submit it in Schoology.